Well, we now come to a very important discussion of relation between potential and intensity. So, for a brief review, I would like to call that intensity, as we have already learned, is the force by the charge. Eventually, we went on to write it as Q into E. And the potential that we are trying to correlate was given as the work, which is Q into del V. So now we would like to utilize these two equations together in order to get a particular relation. Now let's see how that can be availed. So you can put the potential difference del V as W by Q, and the work, as we have already done in many cases, is force times displacement. And the force, as we have just learned, is the product of Q into E. So that gives you the relation where you can write that del V or V simply is E into D. And this particular relation, V is equal to E into D, can be put like this, as E is equal to V by D. And the unit here of intensity is very important, which is volt per meter. If you just remember that we previously had an intensity which was force by charge. So I think all of you will be able to tell me that this unit should be Newton per Coulomb. So here we have a very important aspect of intensity. That's just by getting the unit, you can know that which formula for intensity I should use in a particular numerical. So this is one very important point that I would like to tell you, that this aspect is very important. Well, now coming to the relation between intensity and potential, what we have here is E is V by D. Now in terms of calculus notation, which is very important for us, we put it as E is equal to minus dV by the distance dx. Well, this is called as the potential gradient. This is called as the potential gradient. As you know that anything divided by length is gradient. Say for example, I divided force by length, this force gradient. I divide temperature by length, this temperature gradient, and so on. But what is very important, more important than learning what is potential gradient, is the fact that why we are using this negative sign. This negative sign actually implies that V and X are inversely proportional. But students, many have asked me that, sir, when you say inversely proportional, if I multiply X there, then I find V and X is directly proportional. So what we mean actually by the term that V and X are inversely proportional is simply this, that as X increases, V decreases, and vice versa. Where X decreases, V increases. So this is what we mean by the negative sign. So it is very simple. You see what we mean by the negative sign. We have already learned about it. You have a charge here, you have a point here A, you have a point here B, and we are sure now that you will be able to tell me that VA is greater than VB. So why it is so that VA is greater than VB? Now you have the numerical answer to that. B is less because it is farther away, and A is more as it is close to a particular charge. So this negative sign has a very important role to play here. Now what we do next is find the intensity due to a point charge. How can you do that? Well, we know E is equal to F by Q, and F between two charges, what I can write from Coulomb's force, is capital Q into small q by r squared. Well, I have a Q here, so that gives me the value of intensity due to a unit or point charge. Now, if I take this relation in a generalized way, then I can put it as Q by 4 pi epsilon 0 x squared. So why x squared? Because I am using a more generalized term. Now let me come to this relation of E is equal to minus dV by dx. And then I replace the value of E by Q by 4 pi epsilon naught x square, which is minus dV by dx. Now, if I integrate from dV to minus 1 by 4 pi epsilon naught Q by x square dx, and I put a limit where to where I am integrating. So I am integrating here from infinity to V. From 0 to V, and here from infinity to R. So what does it imply is simply the fact that in infinity the potential is 0, and at a point R the potential is V. So this results to Q by 4 pi epsilon 0 R. Why this becomes positive is the fact that integration of dx by x square is nothing but minus 1 by x. So this minus and this minus becomes positive. So finally, we have a relation of potential which gives you V is equal to Q by 4 pi epsilon 0 R, and intensity which was Q by 4 pi epsilon 0 R square. So we have V varying as 1 by R, and we have E varying as 1 by R square. So this is all you have to remember for the time being. Thank you.